electric current is nothing that's too difficult to understand. Imagine, if you will, you're standing next to a river and somebody asks you to measure the current of that river. Well, you'd likely think to yourself, well, if I'm standing here and I'm staring down at this one section of the river, you'll probably see some water flowing by. And I think most people can kind of understand that if I want to know the current of this river, then I need to kind of think about how much water is either passing by me or passing through this kind of rectangle that I've defined here in a given amount of time. And that's exactly how you find current in a river. How much water flows by a specific point in a specific amount of time. If more water is flowing by every second, for example, as opposed to some time where less water was flowing by per second, then you say that's a higher current. Well, electrical current is essentially the same thing, but don't imagine that you're standing next to a river. Imagine you're standing next to some kind of wire that's been plugged into a wall. The current is just going to be the flow of electric charge past you as opposed to the amount of water. So the variable for electric current is the capital I, and it's found by dividing the charge, or the amount of charge that passes by a specific point in a specific amount of time. Now we use the equation I equals Q over T, I being the current, which we measure in a unit called amperes. You sometimes might hear it referred to as amps, or maybe just a letter A, a capital A, but it's measured in amperes. Q is the charge, which we've discussed previously, that is measured in coulombs, but now officially the variable for charge is Q, and time is T, and that of course is measured in seconds as always. So much like that river example, if I know how much charge is passing by in a given amount of time, I can figure out the electric current. So there's only two things we need to make sure, one other thing we have to make sure you understand, because you will definitely come across it. There's something known as real current versus conventional current. I'm going to discuss both. I always use real current in this course because I don't know, I'm old and I think that we should go with what's right. But I'm going to show you both because you technically will see both. So we know from our discussions that when I connect a piece of conducting wire and I form a complete circuit with this battery, we know at this point that's the electrons, since protons can't move, the electrons will leave the negative terminal, go through that wire, and arrive at the positive terminal. That is what is really happening inside of this battery. Current always really flows from the negative to the positive terminal because the electrons, the negative charges, are the charges that actually move. We didn't always know that though, so electricity was kind of studied by Ben Franklin and some others well before we understood what the atom was and what protons and electrons and neutrons were. So at some point in the past, we kind of had to take a guess. We didn't exactly guess correctly, and for quite a while before the discovery of the electron, we thought that charge flowed from the positive to the negative terminal. Now, this is known as conventional current, and this is what you will probably see in quite a few physics textbooks. This is what electricians will utilize primarily. It's wrong in the sense that it's not positive charges that are moving, it's negative electrons that are moving to the positive. But if you use conventional current, you won't necessarily get the wrong answer. The math still works out, you'll still arrive at the same calculations, but we just have to understand that conventional current is not conceptually accurate, even though mathematically it'll give us all the same results. So I will always be using real current. In this course, we're going to use real current, but do understand that there is this term called conventional current, and if you do see some explanation online, whether it be a video or a diagram, if you see them saying that positive charges are going to the negative side, again, conceptually it's wrong, but in terms of analyzing circuits, that is what we call conventional current, so it's not necessarily wrong. It won't give you the wrong results. Again, I'm a little bit of a stickler for what's really happening, so just understand the difference between real and conventional current.